For example, the square root of 5 is 2.2360679, and the decimal expansion never ends. Well, in this video, we will learn how to estimate the value of square roots so that we can get a general idea of their value. Recall that when we take the square root of a number, we are asking ourselves what number times itself will equal the number under the square root. For example, the square root of 9 is 3 because 3 times 3 equals 9. Now, some numbers have a square root that equals a whole number, and these numbers are known as the perfect square numbers. Here are the square roots of the first 10 perfect square numbers, which you will want to become familiar with. These probably look familiar from multiplication facts, like 8 times 8 equals 64, so the square root of 64 is 8. It is helpful to get familiar with the next few perfect squares too, like the square root of 121 is 11, the square root of 144 is 12, the square root of 169 is 13, the square root of 196 is 14, and the square root of 225 is 15. Numbers that aren't perfect squares have square roots that are never-ending decimals. Now, since non-perfect squares have such long decimal expansions, it is helpful to be able to estimate the value of their square roots, because these values will be way too much to remember. Now let's work through some examples to see a few ways that we can estimate the square roots. Example 1. Which two integers is the square root of 8 between? We can figure this out by finding the perfect square numbers that are just below and just above 8. 8 is between 4 and 9, so the square root of 8 is between the square root of 4 and the square root of 9. Now the square root of 4 equals 2, and the square root of 9 equals 3. So the square root of 8 is greater than 2, but less than 3. So we know that the square root of 8 falls between the integers 2 and 3. Here's another example. This time, let's look at how we can determine a good estimate out to the 10th place. Now, which number is closest to the square root of 3? 0.3, 1.3, 0.7, or 1.7? We will start by finding the perfect square numbers just above and below 3. 3 is between 1 and 4, so the square root of 3 is between the square root of 1 and the square root of 4. Now, in order to estimate the decimal value of the square root of 3, we need to determine whether 3 is closer to 1 or 4, or if it is approximately in the middle of these two numbers. Now, 3 is a bit closer to 4 than it is to 1, so the square root of 3 is slightly closer to the square root of 4 than it is to the square root of 1. Now, when we take the square root of 1, we will get 1, and the square root of 4 is 2. Good estimates that are between 1 and 2, but a little closer to 2, can range from 1.6 to 1.8. Now, taking a look back at our choices, 1.7 is going to be the closest to the square root of 3. Let's try one more. Which number is closest to the square root of 126? 10.5, 10.9, 11.2, or 11.7? We will start by finding the two perfect squares that 126 falls between. 126 falls between the perfect squares of 121 and 144. 126 is closer to 121 than it is to 144. So the square root of 126 will be closer to the square root of 121 than the square root of 144. Now we take the square root of our perfect square numbers and we get 11 and 12. So our estimate is going to be greater than 11, but less than 12. Now, since the square root of 126 is closer to the square root of 121, our estimates will be closer to 11. So a good estimate will range from about 11.1 to 11.3. Now, looking back at our options, 11.2 will be a good estimate for the number closest to the square root of 126.